Okay friends, very good evening. For this semester we are going to discuss about RFIC basic architecture. So basic architecture in also um, also decides the basic design. So RF integrated circuits design. So what is the frequency spectrum of this RFIC basic architect RFIC integrated circuits is 1 gigahertz to 3 gigahertz. And then coming to after RF frequencies, then immediately we will talk about the microwave frequency spectrum. That's the range from 3 gigahertz to 30 gigahertz. After that we have millimeter waves, and those are and that frequency spectrum which involves the optical fiber communications. Okay, next, optical fiber communication. Okay, next to what is RFIC basic architecture? RFIC design is an exciting area for research or product development technologies. And then what are the applications of applications of RFIC? Wireless communications, radar, navigation, remote sensing, automobile and highways, sensors, medical applications, and also radio astronomy. And then RF transceivers. So what are RF transceivers? These transceivers which are the same antenna will behaves like both transmitter and receiver. Okay, will behaves like both transmitter and receiver section. And then RF transceiver antenna is connected to RF section, and these RF section signals will be given to baseband section, and these baseband section signals are again goes to RF section. RF section consists of mostly analog circuits, whereas the entire signal processing or data processing will be done in the baseband section. Okay, RF section mainly consists of analog circuits. Baseband section mainly consists of digital signals, and it processes the data which should be sent to or received from RF part. Which to be sent or received from RF part. The concept of RFIC is also called as circuits for cell phones. And simple communication system is shown below. Is shown in the below figure. So here the basic architecture is represented, and this basic architecture involves the transmitter section, receiver section, duplexer, antenna, baseband processor, microphone, and speaker. Okay, these are the main blocks which are involved in the basic architecture of RFIC. Mm, and then the through mic we are processing the signal. That signal will be we are transmitting the signal through mic, and that signal will be processed in baseband processor, and this baseband processor converts the digital signal into analog signal, and this analog signal will be sent to transmitter section, and in transmitter section only it filters the analog signal, and then it allows to the mixer. So in mixer what will be happening means the signal from filter is mixing with the signal from local oscillator, and and increases the range of the frequency and range of the signal, and that immediately that frequency or that signal will be sent to power amplifier. So here the local oscillator, transmitter local oscillator, which behaves like up conversion. Up conversion means we are increasing the frequency from low to high. Then transmitter, so the signal from power amplifier is sent to duplexer, and towards the duplexer it will be transmitted to antenna, and towards the antenna the signal will be blasted into the atmosphere with maximum power strength. With maximum power strength if it is transmitted, then the signal will be the signal will be detected very soon and with very clarity. Okay, next the same signal will be detected by the antenna, and that antenna will be centered towards the duplexer, and in duplexer the signal will be isolates the and in duplexer the signal will be isolates to the receiver section, and in receiver section what are the blocks involved. So what are the blocks involved in receiver section? In receiver section the signal will be detected very tiny signal. So the tiny signal will be amplified in low noise amplifier, and this signal will be sent it to mixer. In mixer only the signal will be mixing with the receiver local oscillator frequencies, and then here the down conversion is possible. That means the high frequency signal to we are converting into low frequency signal, and that signal will be allowed to the filter, and that analog signal will be filtered, and that filtered signal is again converted into digital signal with the help of A to D converters, and with the A to D converters the signal will be again sent to baseband processor. In baseband processor the signal will be detected to the receiver or catches the receiver with the help of speaker. So antenna. The first and foremost thing that it has something called an antenna. The cell phone has inside it an antenna. Now there is a transmitter and there is a receiver. Both transmitter and receiver are going to use the same antenna. How is it possible? For this there is something called, it is like a switch. It is called a duplexer. Now this switch separates the transmit path from the receiver path. So see the figure, the antenna will be connected to duplexer. The duplexer isolates the transmitter section and the receiver section, and when we are transmitting the signal, the transmission path will be opened, and while when we are receiving the signal, then receiver path will be open. The switch, the duplexer switch seems to be like that. Duplexer. So what is duplexer? It is a mechanical switch used here to separable or to isolate the transmitter section and receiver section. If not, we can hear at receive side whatever transmitted, whatever we broadcasting the signal. So it could be a filter, provides good isolation. It must have low attenuation if transmitter and receiver are not working. So the switch the duplexer seems to be like that. Next, RF receiver. So here RF receiver block diagram like that. RF receiver consists of mainly two sections, that is RF section and baseband section. So what is RF section? RF section consists of filter, low noise amplifier and mixer. Baseband section consists of A to D converter, demodulator and DSP, and again digital to analog converter, and that signal will be allowed to the baseband signal will be allowed. Okay. Next, in the RF part, the received signal is filtered and amplified by a low noise amplifier, then image rejection and down conversion is performed. So, decoding and demodulation is performed in baseband section. So, RF transmitter. So what is RF transmitter? Baseband signal. Baseband signal, it is sent to A to D converter, modulation and DSP. And towards the modulation and DSP, the signal will be goes to DAC. Goes to DAC. That means digital to analog converter, and digital to analog converter to up conversion. Up conversion in sense we are increasing the range of frequency, and that increased frequency we will be sent it to power amplifier, and towards the power amplifier the antenna will be transmitted. Okay, so there are two sections, that one is baseband section, another one is RF section. Baseband signal is comprised and coded and modulated in the first step. In the RF part, up conversion is performed and the signal is amplified in order to be transmitted. In the RF part, up conversion is performed and the signal is amplified in order to be transmitted. RF receiver. So what is RF receiver? Here the first thing that we need is something called a low noise amplifier. So it receives a very tiny signal from the atmosphere and this tiny signal has to be amplified. So low noise means it does not add too much of its own. Okay, it only the low noise amplifier only adds a little amount of noise, not too much noise. Next, RF receiver. So RF receiver, what will be present in RF receiver? So RF receiver, at a low noise amplifier does not add too much noise. Therefore, a low noise amplifier cannot remove the noise and keep the signal. Okay, and keeps the signal. It has to handle both the noise and the signal that it has already received. Except passive lossless system, every other system adds noise. Okay, and any other system adds noise. Only except lossless system. This except lossless system can't absorb too much of power. So these are considered as lossless system. So RF transmitter. So what is RF transmitter? Here, just before sending the signal to the antenna through duplexer, we need something called a power amplifier. It plays as much possible, much power as possible into the atmosphere so that the base station can receive clearly. That is the last block on the transmitter chain. Okay, what is the last block in the transmitter chain? Power amplifier is the last block in the transmitter chain. What is RF receiver? The next block in receive chain is mixer. It is also called multiplier and it down converts the high frequency to low frequency or required frequency. So and also this is done after and this is done after local right after LNA low noise amplifier and also one thing LO. So what is LO? Local oscillator. RX, it denotes the receiver section. So RFIC basic architecture law, architecture in architecture RF transmitter. So what is RF transmitter? It transmits chain. Next block is mixer. What is going to happen before power amplifier? Something similar to as we want to work with low frequency. Okay, so what is happening? Power amplifier something similar to as we want to work with low frequency. So local oscillator can transmit low frequency signals or high frequency. The local oscillator also gives the high frequency signals. LO stands for local oscillator. The local oscillator for transmitter is also typically different from the local oscillator of the receiver. That is LOTX is different from the LORX. So these two frequencies are generated on the same chip. They are different. So even though two frequencies are generated on the same chip, they are different. And these two frequencies mix with the RF signal or with the baseband signal and create the low frequency or the high frequency, whatever you want depending on transmitter or receiver. And these two frequencies mix with the radio frequency signal or with the baseband signal and create the low frequency or the high frequency, whatever you want depending on transmitter or receiver. So why these two frequencies are different? Local oscillator up conversion oscillator and down conversion oscillator. Why these two frequencies are different? And in order to equal or in order to synchronize these two frequencies, we are going to another techniques. So these two frequencies are generated on the chip at the same time or different times based on the technique called TDMA or FDMA. Based on the technique called TDMA or FDMA. So these two frequencies have to be synchronized with the base station frequencies. Base station frequencies, we need extremely accurate synchronization between the handheld and base station. So in this system, both base station and receive stations are operated at same frequency. Okay, so both base station signal and receiver station are operated at the same frequency. Here we require frequency synchronization. For this, frequency synthesizer is used. It is nothing but a PLL. Using this we can avoid offset problems. Using this we can avoid offset problems. So this is the overall basic architecture of RFIC, which involves certain blocks that are duplexer, transmitter section and receiver section, A to D converters, D to A converters, and also baseband processor through microphone and the baseband processor through speaker. Okay. But this entire architecture will be presented on the same IC. Okay, and also the same antenna, will be used for both, and the same antenna will be used for both transmitting and receiving. Thank you, friends.